Hello, this is Steve Palladino. I'm coach and consultant at Palladino Power Project. We have a Facebook group presence, and what I want to do today is go over a very handy calculator, actually a conversion tool that the folks at Stryd created that includes both altitude as well as temperature, humidity, actually three things. That it includes three variables that includes for converting target power at one set of conditions to a power target at a different set of conditions. So without any further introduction, let me go ahead and show you the tool. The tool is called the Power Race Predictor. It's from Stryd. Um, there are links to it on the Stryd Facebook group as well as the Palladino Power Project Facebook group. And it's more than a race power predictor conversion tool. It can be used for training or racing. So let's go into how it works. So um, you're going to put in entries for a number of variables. For example, let me use an example. Someone that is training at Flagstaff and going down to sea level race or sea level training. It doesn't really matter in this case. But let's say they're going from Flagstaff down to sea level for either race or vacation, where they're going to be doing some training or training camp or what have you. Let's just say that the person's FTP at altitude at Flagstaff is 300 feet, and this portion that I'm working on right now here with the colors, that's something I added. It's just a converter because I don't natively work in units of Celsius and meters of altitude. I do work interchangeably in meters and miles, but for these I like to have a calculator to be accurate. So 6,900 feet is 2103, which I just entered here into the from. That's where they're coming from. And let's say their typical training temperature has been 50 degrees. So it comes down to here, and I'll type in 10 for that's 10 degrees Celsius, 50 degrees Fahrenheit, and let's say it's 20% humidity, just for example. They're going down to a location that's about 150 feet. So actually, I got to make that conversion here. 150 feet is about 46 meters. And let's say they're going to a warmer temperature. Let's say their running temperature, their typical running environment is going to be about 75 degrees Fahrenheit, which is 23.9 degrees Celsius. And let's say the humidity is a bit higher there. Let's say it's 75% humidity where they're going. So let's say their CP was 300 up at Flagstaff, and down at sea level now, as I hit the enter button, they're no doubt they're gaining some positive effect on power because of the lower altitude, but they're losing some of that back because of the conditions being warmer and more humid. So for this person, their CP would be about 314.7. We'll just call it 315 watts at sea level. And then you could then use that value for race power targeting or training targets that are done as a percentage of FTP or CP. You could do the same thing. Let's say if you knew, hey, my race power target for this race, let's say is 280 watts is what I figured out. I just plug that in, and now it's 294 watts with these same condition variables. Now I'm going to just show you something here. Let's look at this. It calls converted percentage. Actually, it's a conversion factor. The percentage is 4.9%. 1.049 is 4.9%. So you gain 4.9% on your power going from this 6,900 feet down to sea level, roughly 150 feet, say, and we're going from 50 degrees down, or 50/10 down to 75/20, and a little bit higher humidity. Let's take the weather out of it. Let's say that the conditions were going to be identical for some random reason other than this explanation. So we keep those the same. Now, if you look over here, if conditions of heat and humidity didn't change, the effects of going strictly just from going from high altitude to sea level would be an 8.1% gain in power. Let's give another example. Let's say the person is at sea level, 150 feet. We'll just use that, 46 meters once again. But let's say that they tested FTP. FTP is 300 for this example. Let's say that they tested it, say at 65 degrees Fahrenheit. That is 18.3. And let's say that they're going to be running in 80-degree weather for some reason, a little heat spell. So 26.7 on the temperature, and let's say the humidity smidges up a little bit, and we're talking about 50% in this case, just for example. So in this example, no change in elevation. They're staying home. They're just hitting a heat wave with a little bit more humidity. How do they adjust? Well, their former FTP at those conditions of 65 degrees with 20% humidity now becomes 291 watts at 80 degrees with 50% humidity. They have a 3% loss in power. Then you then take your revised CP, plug that into your whatever way you're generating your workout intensities, and base it off of a 291 watt FTP. So a really cool calculator, and it allows you to account for the effects of heat, humidity, and altitude on power, and so that you can be a little bit more nuanced, a little less error prone in your training and racing targets that might be based on a set of conditions that are not the same as what you're going to be training and racing in. So hopefully this helps. Thank you for watching, and wishing you well. Bye-bye.